All right, hi everybody. We are going to talk about how to build what I'm calling a DigiPi. It's a Pi Zero, an audio board, and a little screen, and some additional components for notification and switching an amateur radio. Check out my other videos if you want to see this kind of in action. This is just going to be a series of video segments to show you how to kind of basically assemble this thing. There's going to be some soldering and then some software, obviously. These are the components you're going to need. The LEDs are totally optional. I like to have those for push to talk. What else we got here? I can use the Sharpie, is not required. The field effect transistor is just a switch. Don't let the fancy name fool you. You need to source one of these. We got regular resistors. You need one of the 100Ks to put in with the FET, and these other little guys are current limiting resistors for the diodes if you want to use those. And then at the center of this, of course, we have the Pi Zero, and the Pi Zero wireless is the important part. That means it has Wi-Fi on board. And the FE Pi Zero, this one's really hard to find right now. It's FE Pi Audio Z. The original manufacturer stopped making them. There is another guy who's putting these together, Bud, and I will put together a link to Bud's website, who got the Gerber files for these and is making limited runs of these audio boards. So you could also use a USB adapter, but keep in mind the Debian kernel has problems with the USB dongles. And it takes a while for the USB transactions to complete, and it'll kind of hold the transmitter on longer than it needs to be. You're going to need a stacking header, since we're going to have two things on top of the Pis. We're going to have the Pi, and then on top of that, we're going to stack this audio board, and then we're going to stack a monitor. I've been using these Adafruit monitors. Either one will work. They have to use the serial port protocol because this uses the other pins. That way, there's no conflict. So these need to be an SPI based monitor, serial port interface. And this 1.3 inch TFT works really well. It's about the same size as all of this. And you can use this little tiny guy also. So anyways, that's the parts list. And then down here is the actual wiring diagram. I'm going to try and hold really still here so you can read this. I don't have like a PDF of this yet. What I should do is scan it. So at the bottom, we see the Pi we just talked about, and this is the top and bottom of the FE Pi audio card. And we're going to, instead of like plugging into these jacks, we're going to actually solder on some of these signals onto these. So this would be the, what's this one? This is the line out, and this is the line in. This is the ground here in the center, and there's actually multiple pins for line out, which is cool. And there's multiple pins down here for line in. So it gives you lots of stuff to solder to. Pretty cool. And then I just use this as a common ground for everything. And then coming from your radio, that's over here. I'm using RJ12. That's this guy. He's going to have 4 signals you're interested in: push to talk, radio in, ground, and radio out. Maybe your radio has a speaker out. That's fine too. You can use the jack actually for line in if you have with a speaker output. Do that quite a bit. And then of course the FET here. This does the switching. A FET, don't let the complicated name be scary. And this is just a switch. Now, all it does, a FET will close the right side with the left side if you apply voltage to the center. That's it. It's a switch. So you apply voltage to the center of a FET, and suddenly there's continuity between the outside legs. That's it. And that's basically, we're pulling our push-to-talk signal to ground. This little resistor in here, it doesn't look like it does anything, but FETs are so sensitive that if static electricity builds up on that center leg there, on the gate, it could potentially trigger the FET. So that resistor is basically to drain off any unwanted charge between the center leg and ground. That one is kind of necessary. At least I see it in most circuits. And if you want to do like a carrier detect line, you want to solder an LED to the GPIO pin that the Dire Wolf uses for carrier detect. And you can also look at assign another GPIO pins to other LEDs if you want. So the one thing you have to solder here is the push to talk pin, whatever that happens to be. So push to talk here, I think I use GPIO 24. I think we're going to use 12 or 16 this time, just to get away from the monitor screen, so we're not messing with its pins. And the push to talk just pulls it to ground through the FET whenever Dire Wolf wants to transmit. That's how this works. This is the parts list. So anyways, this is everything we need to build an APRS packet radio, what I call DigiPi, and that'll work with the Direwolf APRS packet. It'll work with BBX, AX.25, it'll work with WinLink, all of that. These are the parts, and we're going to do some smashing together, and we're going to do a little bit of soldering as well. I'm just going to do some video segments to help out with the more awkward parts. Okay, that's parts and stuff. I'm going to start assembling now, and I'll give you another video segment here in a second. Okay, if you have 3 or 4 hands, you might want to test to make sure your LEDs are working properly and that the GPIO pins are working properly. I like to do this. I think there's one Pi where one of the GPIO pins just wouldn't work at all. So I want to test 12 and 16. Those are the ones I'm going to use here. And remember, the short leg on the diode is the positive one, or the longer leg is the positive leg. And I wrote a bash or a Python script that just cycles a 12 and 16 on and off. So this is 16 and it appears to be working. So I'm going to go ahead and use that. I'm just connecting a diode with one of the little 280 ohm resistors. So I think that's what they are. And sure enough, 16 is blinking. That's what we want. And strip back the white, let's see, we want to strip back about 2.5 inches of the RG12 connector. It looks like a phone cable, but it has, 6 wires in it. We only need 3 wires. We want the white, black, red, and yellow. So I'm going to go ahead and trim off the other guys. We just need those 4 signals, and then that's it. About 2.5 inches, strip the insulation back. Keep the insulation, don't cut it off. We're going to tuck that in behind the Pi. It gives it a little more structure anyway. Anyways, just like this. All right, and then we're going to solder this resistor, which is 100K, onto the left leg. That's the source, if I remember right. And then we're going to solder the other end of the resistor to the gate, which is the center there. And I put some flux on there. I'm just getting started. Don't forget to put shrink tubing on there. Shrink tubing at each phase. All right, this is the push-to-talk circuit coming together. Don't forget to put on that shrink tubing, and don't forget we need to still solder on 2 more wires to this. Basically the 2 that I've mangled just here. Yeah, don't forget that. So make sure you have a little bit of something exposed for the source and the gate. And of course, connect the white wire to the drain on our FET. That's the rightmost peg there with the flat side of the FET facing you. That's our push-to-talk wire coming from the radio, and this FET's going to ground that out when Direwolf wants to open the transmitter. And it doesn't have to be pretty. We're going to cover all this up with shrink tubing. Don't forget the shrink tubing. And no one will know how messy this is. Your secret will be safe with me. So let's look back at the Raspberry Pi. Your Pi may or may not have this header soldered onto it already. What is that, a 40-pin header? You're going to need to solder all of those on typically. It's not as bad as it seems. Once you get a couple of them and you get it on nice and flat, do the corners first. And then just bust through the rest of them. It doesn't have to look good either. I mean, you're going to melt the lacquer on there a little bit, and that's fine. That's completely fine. Buying these headers, you can get them on Amazon anywhere. What I do is I like these cases. The Vil Ross case. I don't know if that's a thing. But they actually ship the Raspberry Pi Zero headers in the case. If you look in the case, you'll find them. So go ahead and solder on this header. I'd already done it a long while back just because I was testing this Pi for some other stuff. And that's that. So, and after we do that, we're going to put on our stacking header on top of that and solder the FE-Pi audio board onto that, but using as little solder as possible. And over here, I don't know if I showed you guys, but I have the white wire on there. I'm just going to leave this here for now. We've got some more work to do with this guy, but first we need to put the header on there and put on our stacking header, and then solder on, put this guy on top of the stacking header. So we've got some more soldering to do. All right, put the stacking header. Remember, this is a stacking header where the pins are really high because we need to put a third thing in here. This is the stacking header attached to the audio board. So how tall those pins are, they go right through. I'm just going to solder the necessary pins. There's voltage and ground, and if you look up, there's a website, maybe I'll put a link to it. It shows which pins are actually in use. I'm just going to solder those pins and maybe a couple of grounds at first and then test it out. I don't want too much solder to creep up these pins because it might make it difficult to put the display on top of this. So I'm just going to use this tiniest amount of solder on just the pins that are absolutely necessary here. I'm going to go look up those pins right now. All right, let's see if I can video a soldering disaster here. So 1, 2, 3, 4, 5, 6. So sixth one down, that's GPIO 12, I think. A little bit of heat, tiny amount of solder. Soldering's kind of boring, so let's see, we're going to do GPIO 20. And kitty corner from that, do use a magnifier. Oh man. Really harder to do with the actual riser. Alright. A lot of heat. Touch solder. And let it wick in there. Yeah, it looks good. Okay, at this point we have the Raspberry Pi, which we really haven't messed with other than putting this header on, and we've got this riser, this extended stacking header soldered onto the FEPi audio board. And I just soldered the pins that I know it needed. You can look that up. I've got a website somewhere for that. And ideally you want to, maybe at some point solder them all. My only concern is if a bunch of solder wicks up these risers, this might not slide down flush. So I'm really kind of hesitant to solder in, do any extra pins here on this side. Maybe I'll do this side just for extra strength. But yeah, do keep in mind that the solder is basically what holds it on there and keeps it strong. So this is what we have. So we got a Pi with a header on it. We got a FEPi audio board with a stacking header on it. And I'm just going to smash these together. I'm going to do a quick test, before I really start soldering on the audio board. I want to make absolutely sure that I didn't get a dud. So I've got the audio board on there. Eventually we're going to put our screen on this side, not this side, but this side. But before I solder any more onto the audio board, I'm going to test it. So I'm going to go ahead and plug her in, and I'm going to make sure, what am I going to do? There's an image in there. I'm just going to make sure that, oops, this is the power one over here. I'm just going to make sure Direwolf sees the audio card, because if it's a dud, now is a really good time to yank it out of there. So I'm going to go over to the computer, log into this thing, fire up Direwolf, and see if it sees the audio device. So over on the computer, I've logged into the Pi remotely. That's distorted. Run ALSA Mixer. And at that point, you'll see the mixing board for the FEPi, and most importantly, you're going to see card FEPi audio. So we know the Pi is working, and we know it's talking to the audio card if this works at all, and so we can continue at this point. So red, black, and yellow, they're going to solder to the bottom of the FEPi audio board. Yellow is the longest stretch, so make sure yellow makes it across the board. Strip back more insulation if you need to. And I don't have a good way to strip this wire, to be honest. It's just teeth, maybe? I don't know. Anyways, I'm going to solder these into position. That's the bottom of the FEPi. And basically we've got the red, black, and yellow over here. We're going to solder them to these locations on the board. So this is the line out positive, this is the line out ground, this is the line in positive. I don't know why they have 4 pins for positive, but it really makes it easy to solder to. And the line out ground. And just to give you an idea, there they are. All right, so hopefully I'll come back and this will be a hot mess of solder. All right, we've got red, black, and yellow cut and tinned. While you're tinning, make sure you melt the insulation is going to melt back a little bit. So you're going to chase the insulation down the wire, and it'll harden up and stop melting at some point. Make the black and red a little shorter, and make the yellow a little longer, so it can reach over to the appropriate line in or line out or ground. That wasn't too bad. All right, we got the line in, line out, and ground hooked up to the RJ12 cable. And we still got this guy hanging out over here. Remember, we worked on him first. We're going to start hooking him up pretty soon. And that's it. And we solder on the center connector on the FET right here. That's this big mess. Don't forget the shrink wrap. And then we're going to run the other end of this through the hole on the back side here, because we're going to solder on top of this board here in a second. That's our push to talk line. Alright, at this stage we want to attach the push to talk wire to the 5th pin up, 1, 2, 3, 4, 5, and that's GPIO 12. I want to do it at the very base. That's going to be really tricky. Do some weaving if you need to, get some pressure on it. So I've pre-soldered that pin and I've pre-tinned this wire. I should just put them together and heat them up. And it wasn't too much fuss, just to put the push to talk wire onto GPIO 12 there. And she's just leaning against the post, and just tiniest amount of solder. And now we're going to hook up the ground wire to the FET. That's this wire here. I shrunk these guys just so I could have a little more handling strength. You really don't want to break these FET legs off. So this ground wire, it ends here, and I'm just going to hook it up to this ground because it's nearby and I've already messed with it. I don't know, have a single ground I guess for these guys. Okay, the ground wire is attached to the FET now, and it's just kind of hanging here in the air. What I want to do now is focus the camera and I can take that, if I trim them off, I'm going to put them right where that red wire is, because that's a ground point right there. So I'm going to solder this guy to where that red wire is. Okay, it's starting to look like a digipeater now. I got that the ground on the FET here grounded next to the red wire here, and actually this is pretty much ready to go now. The push to talk is hooked up. We could actually fire this up and let it rock. What we don't have any of is the LEDs, you know, like for the carrier detect and transmit. And what I'd like to do, I think on this one, I'm going to insert those LEDs through these ground holes. And maybe epoxy them in. I make a red, blue, and green or something. I haven't really decided yet. But at this point, it meets the minimum functionality. We could technically fire this up and see what happens. All right, and then button up the FET with some shrink tubing. I haven't heated this up yet because I haven't actually got an end-to-end test. Also, for some of the primary wire, you know, either recycle some of your RJ12. I just use some of this phone line stuff that I've had laying around. Melt the insulation back when you do cut it. I've just been ripping this stuff off out of that. And then, in fact, that's what this yellow wire is. It's just some phone line stuff that I found. And I think everything's hooked up. I'm going to go ahead and connect the Pi. We're going to do a functionality test, even though we don't have any LEDs. And so the moment of truth is coming up. Did we get it right? So I can go ahead and jam the Raspberry Pi on there, like that. And now we have basically a working TNC. I've got an adapter cable for this end that will connect me to the Yaesu FTM 400. There's a keystone jack. I'll see if I can show you guys that. That'll hook up to that. That basically helps me map the pins. And then I have an adapter cable basically for every radio I own that can possibly that I'd want to use for packet. Okay, so I'm going to go spin this up on and power it up and see what happens. I need to hook it up to a radio first. I might do some continuity tests first just to make sure I'm not shorting anything out, but hopefully when we come back I'll have this hooked up to something and it'll actually be digipeating. All right, I powered it up. I logged into it. Direwolf is running on it now. That's our TNC software. This is it. I haven't hooked it into the FTM 400 yet. This is that. That's really the moment of truth. If it's going to smoke, it's going to do it now. Though honestly, I don't think it will. I don't think I can hook this up and video at the same time. So this is where I'm at. The moment of truth. All right, I've waited a minute or so here, and the other thing you might notice, I just added this RF choke. That's necessary because this becomes the negative half of the antenna that ground wire does, and if a lot of RF gets into the audio card, it'll just lock up. In fact, just now I noticed it transmitted a packet and then just quit and it stopped reporting packets altogether. So that was the sound card just completely locking up due to RF. So get a choke for sure. That's going to be a required part. Usually it's not an issue on this radio. It's definitely an issue on the HT. I've seen that before. So here we go. We're going to send a packet. You're watching over here for the receive and transmit. And that was it. I got duplicate mic exchange back, and we're in business. And we can watch the Direwolf log over here if you want. Here come the packets. In fact, there's KM6LYW. That was me right there. That's the packet we just did. You can see we received this packet and then we retransmitted it here. So that's a receive and a retransmit. And the rest of those are receives. So at this point, you've got a kind of a working system. I mean, as long as you're just running Direwolf, there's a lot of software we can still play with here. Feel like you guys can hear me. We haven't talked about software at all. So right now it's just running straight up Direwolf and using those GPL pins 12 and 16 for push to talk and data carrier to detect respectively. So what we want to do now is zip over back here. Maybe hook up some LEDs, like, so that when there's a carrier area, there's no green light. When there's a transmit, there's no red light. I don't know. Maybe we need those. Maybe we don't. I don't know. We're gonna put that display on there, and that display actually has a red and green, icon that lights up and stuff, and plus a Bluetooth light. But I will look into this a little more. I'm going to put the display on here now and just see what happens, make sure all that works, and then I'll consider putting those LEDs. I kind of want to put the LEDs right here in these 3 holes. They'll actually come up and fit through there, and you can epoxy those in. So right now we got a working digi or packet radio thing, but we can make it even cooler. And I'm going to go ahead and shrink wrap this that FET. We don't want that to hang out there either. All right, so hopefully more soon. I'm going to get that display on there. All right, this is the completed product. There's 0 chance this is going to let me focus. No chance. Let me turn the light on. Turn the light off for dramatic effect. Okay, maybe you can kind of see it. So you can see the radio working, making a lot of noise, and you can see stations being added to the list there. All right, by some miracle, we got some focus. I see the green lights flashing. That's good. We're getting messages through. We got a station list. I'm going to smash the radios together. I'm going to transmit a packet here. We're going to see what happens. All right. We should see the green light LED light up over on the left, and then the red. I'll try it again. There we go. And we got the red LED, and we see my call sign show up there. We are in business. There's KM6LYW just sent a packet, and of course it was DigiPi'd on the Yaesu, and we have an APRS Digi. This can be a lot of different things. This is just this is Dire Watch. This software is called Dire Watch, and it just watches the Direwolf log and lists all the call signs that are there. It also watches the GPIO pins. That's how you get the green and red flashing LEDs. That's another packet. I think it's been too soon though. Green LED. Nope, we got a red. It worked. And there I am again. KM6LYW at the bottom there. And we got another packet. and they just keep rolling in. So we are working. So the hardware is basically complete unless you want to add some LEDs, which I talked about earlier. What I want to do is do a whole nother video for the software. So if you've got to have this display software right now, look on GitHub for Direwatch. Direwatch, Direwatch, and that's the software for this display. And whatever you're doing with Direwolf, it'll just look at the log file. It's pretty self-explanatory. Actually, it's pretty simple. And we'll go from there. So what I'd like to do is add WinLink screens and stuff like that too. But the hardware is done. You can see our little push to talk wire there is on GPIO 12. I'll button this up a little better. Still got the FET hanging out there. We can kind of get that back on there. And we'll put some heat sink on there. I don't know what we're going to do about a case, but I don't know. We'll see how it goes from there. So this video is already really long. I'm going to go ahead and stop it here. And so this is part 1. So part 2 is going to be the software. I don't know what we're going to call it, but it's going to be the software. There's some PHP scripts. This thing's a web server. It's a Bluetooth server. We can use it with HPRS Droid. So all of that's the software side. But the hardware side seems to be working. And you just saw me build this guy. So again, this is KM6 LYW, Craig in cool California. And I'm clear.